Hi, I'm Julien Hutzemakers from the University of Liège, and today I'm going to talk about the evolution and modeling of the impact of drought on groundwater reserves in Wallonia in the context of climate change. Okay, so in 2017 we had a reasonably big drought in Wallonia, and so the government asked us, the University of Liège and the University of Mons, to assess the impact of a prolonged drought on groundwater. And so we wanted to assess that impact both in terms of groundwater flux and piezometric level. Okay, so how did we do that? We built 8 models of the main aquifers in the region, okay, and then those models we calibrated them, blah blah blah. And then we simulated different kinds of scenarios of different kinds of droughts, okay, to be able to assess both in terms of piezometric evolution and groundwater budgets the impact of drought. Okay, so for the piezometric evolution, what did we do is that we compared those drought scenarios to a base scenario, which is composed of the recharge of mean years consecutively, okay? And we compare that both scenarios on every node of the model, okay? And so we have mean recharge and then the drought. And so for every node of the model, we get to compute a maximal piezometric drawdown and also a recovery time. The recovery time is the time needed to get up to decrease the maximal piezometric drawdown by 90%. Okay, and so we have beautiful maps that are a function of the lithology, but also the presence of rivers, etc. So we have kind of the spatialization of the droughts, but we looked also at the flux of the groundwater at the scale of the whole model for a better understanding of how much under pressure the groundwater body is. Okay, so for every year we compare what comes in of the model and what comes out of the model through infiltration, extraction plants, neighboring aquifers and rivers. Okay, and not only do we do that through graphs, but we also compute small indicators that are represent through numbers how much the groundwater body can be under pressure. Okay, so for every model we have the evolution of how much the fluxes changes throughout the drought, and also we have maps to assess how the piezometric evolution will evolve in time. So both those complementary methods has been used on all 8 of the models, and we gave that to the government for decision making.